Hey, hello, and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem: distinct occurrences. Okay, so we will be given two strings, S and T. So what we want to do is we want to find the number of occurrences of this T, right? Of this T. Okay, the number of subsequent occurrences, the number of subsequent occurrences of this T in S. Okay, so let's see how many occurrences are there, right? So one occurrence is this band, right? One, right? Another occurrence can be the subsequence occurrence, right? When we say subsequence, it need not be contiguous. So BA, this BA, and this N, right? So this is another way. The way is another way is this B and AN, right? This is another way. So there are three ways. There are three ways for the subsequence occurrence of T in S, right? So the characters need not be contiguous, right? So, okay. So this is a problem we want to solve. Okay. Now let's see how we can solve this problem, right? So what we can do is, so let's see. So what we'll do, we'll start with the first characters of both S and T. Okay. And we'll have two choices over here, either to take this B as a match or this B. Okay, so let's see. Okay, so let's say we took this character, right? We took this character as a match. So we'll move ahead with the remaining string. Okay, so if this is I and this is J, right? This is J, this B. So we'll move this J, right? This J and this I. Consider it as a match, right? So we'll move ahead with the remaining string. So let's write A, right? And here AN. Okay, so there'll be another choice. We won't take this B, to not take this B. So we will move ahead, right? And we'll try to find this B in the remaining string. Okay, so as we have not taken this particular B, right? So we will have this band intact, right? We'll have this complete band. Okay, T will be as is. Okay, so let's take this branch now. Okay, so again here so we'll have two choices here again because the first characters are matching. So either to take this, let's take this. So if you take this, we'll take the remaining strings, right? The remaining strings, right? N. And we won't take this, right? We don't want this A. We'll find this A, the match of this A with the remaining with some other A, right? With some other A. So let's move ahead. We will move ahead with the remaining string, right? We're not taking the string, and this T string will be as is, right? This T string will be as is. Okay. Okay. So let's go ahead again. Let's go ahead again. So here the first characters are matching. So we have again two choices here, right? We do again to have two choices. So let's move ahead A, and we'll have empty string here. The another choice is not to take this N. Okay, we'll move ahead. Okay, and this T will be as is because we have not taken N, right? We are not taken N. So here, so in this case, so we have exhausted T, right? We don't have. So that means we have found the match. So when we have found the match, we will return one from here, right? In this case, so there's no match. The first characters, right? The first characters are not matching. So what we'll do, we only have one choice. We only have one choice here to process the remaining string of S, right? So we'll have this N, A, and N as a T string, right? Right? So here again, the characters are matching. So we have two choices here. So when the characters are matching, we have two choices, either to take that character or not take that character, right? So we took the character, for example, right? So here the case will be like this, empty string for T, right? And in this case, so we have not taken this N. Let's not take this N. We will find this N for in the remaining string, right? So here, let's move ahead. This will be the state, right? This will be the state. Now in this case, here we have exhausted T, right? So we have found a way. We have found one way, right? So we'll return one here. So here the characters are not matching, right? So we'll move ahead with the remaining string, right? So we'll exhaust S over here, right? The T string will be as is, okay? Because we have not found the match. So here it is not possible now because we cannot match, right? T is still remaining and we have exhausted S. So here from here we'll return zero, right? So the recursion for, right, the sub branches are done for this particular part. So we have 1 plus 0, right? 1 plus 0 coming from both these branches, right? So we'll return one way, right? We'll return one way. Okay, we'll return one way. So here, so from this branch we are getting 1 as a value, right? So we'll return 1, right? So for this branch we are getting two values from two branches, 1 plus 1, right? 1 plus 1 equal to 2. So we will pass 2, right? So okay, so from this particular left branch we have got 2. The right branch still needs to be solved. Okay, so yeah, let's quickly see it is again going to be the same, right? So here what we have, this both are not matching. So we only have one choice, right? To move ahead with S, the remaining string of S, A, N, A. We have this, right? And A, N we have because A did not match. So here we'll have two choices again, right? We'll have two choices again to take this A, right? So we'll move ahead, right? And this will be the state. This will be the state. And to not take this A, so we will, sorry. it will be NA, right? And AN as is, right? Similarly, in this fashion, whatever we have done here, right? So it will be the same over here as well. Okay. Okay. So one thing to note here is, right? So one thing to note here is there'll also be some repeated sub problems. There'll also be some repeated sub problems. Okay. For example, it's not exactly the same, but yes, there'll be repeated sub problems wherein we might have already solved for ANA and AN. Okay. AN, right? Which is this case, right? ANA and AN in this particular branch, right? So there can be repeated sub problems in this, right? So we need to solve that problem as well. Okay, so let's move ahead with code. Let's code this. Okay, before that, I'll request you, if you got the intuition, I'll request you to subscribe to my channel. Okay, and like the video. Let's quickly solve. So first I'll solve the Java code, and then I'll show the C++ code. Okay, so let's have this. Let's take the length of S, right, and length of T. Okay, let's have this function solve. Okay, and we'll pass I, right? I. For example, let's say int I. This is the counter for a string. In J, this is a counter for T string. Okay, the index for, sorry, the index for S and T strings. Okay, so we'll pass I, J, right? The strings themselves, right? The strings themselves, S and T, right? And N and M. So we'll pass this N and M, right? So let's say, so this solve will return the number of ways, right? So let's return this as well. So what we'll do here, static int solve, right? And we'll have int I, int j, string s, string t, and their lengths m, right? So this is the case. So what we'll do, we'll write the base condition later on. So for example, if the characters are matching, right? S dot char at, right? At I equal to t dot char at j. If they're matching, so what we'll do? So we'll move ahead, right? For example, let's have this take, right? We are taking this value, for example, right? Take equal to solve. So we'll move ahead. I plus 1 will move I and both I and j, right? Both I and j will move, right? S, T, rest will be unchanged, right? So this is this case. So for example, so N and N both match, right? N and N both match. So we are moving ahead, right? We are taking, see, we took the remaining strings. We move I and J as well. So J is now like beyond this. In this case, we have exhausted T basically, right? But we are moving J. Okay. So we have taken this, right? The other option is not to take, right? Other choice is not to take. Solve. So in that case, we'll just move I, right? J will be as is. J is the index for T string, right? M. So here, so in this case, right? So in this particular case, right? So we didn't take this A, right? We didn't take this A. We moved I. That is, we took the remaining string. See, complete, right? But T is as is. T is as AN. So J we are not moving. We are only moving I in not take, right? We are in not take. And simply what we'll do, we will return the number of ways from take and not take, right? The number of ways from take and not take. Because because if you see here, right, in this particular case, right, we didn't take this n, right? We didn't take this. So we took another choice of not taking, right? But still from not taking, we got one way, right? We got one way, right? So we can, by not taking, right, we may find matches of this n or the remaining string, right? In the remaining string of s, right? So here we are adding up the number of ways, right? Here we are adding up the number of ways. Now coming to base condition. What can be the base condition? For example, J is the index of T, right? And we have exhausted T, right? So how it will be? So if it has reached the length, that means we have found the match, we'll return 1. Else, right? If T is not exhausted, but S is exhausted, right? But S is exhausted in this case, there cannot be match because T is still remaining, right? And we have exhausted S, right? So this is a, let's solve this. Okay, there's some problem. Oh, this should be 0. And another thing is, as a number can be big, right? So find the count of distinct occurrence of T modulo 10 is to the power. So we'll take also modulo static int mod equal to 3, 4, 5, 6, 7, 8, and 9, right? Right. And what we'll do, we have to take the modulo of the occurrences, right? Modulo of the occurrences will take mod. So now let's run this. Let's submit it. Mostly it is going to give us TLE. Let's see. Time limit exceeded. Yes, we've got time limit exceeded because we have not solved the problem of repeated subproblems, right? So I mentioned, right? So when we come here, right? So it may be the case that we have solved this. We have solved this particular instance of I and J. right? In some other previous recursion, right? In some other previous recursion, there may be this case, ANA and AN. We have already solved this. So we have to store this, the number of ways, right? At particular I and j, there was some number of way, right? So we need to store this so that we can reuse here. So that we can reuse here. So that's where memorization comes in. So we'll have a DP array, right? We'll have a DP array int DP equal to new int, right? N plus 1 and M plus 1. Okay, and we'll pass this DP in this. So let's have here int DP, right? So what we'll simply do here is we will store, right? We'll store for this particular I and j, right? Whatever the number of occurrences are, okay? So we'll store the state in this DP of ij, right? And hence, so if we have found also one more thing we have to do, we want to initialize this DP with -1, right? Initialize DP with -1. So we have this function as a fill DP -1, right? So we filled with -1 and here. So here we are computing and storing the DP of ij. So whenever we come to the same repeated sub problem, so we can check in this way. How will know if we have had repeated sub problem? So if it is not -1, right? So we'll return DP of ij from here, right? So yes, so now let's compile again. Oh, there's some problem. Yes, we didn't pass DP. So yeah, so here also let me explain this case, right? So if the characters are matching, so we are having two choices. One is to take and one is to not take, right? One is to not take. And if the characters are not matching, so this won't be executed, right? So we'll only have one choice, that is to not take, that is to move ahead with I, right? Okay, so both we are solving both the branches, right? We're solving both the cases, both the choices. Okay, so let's submit it. Oh, there's some problem. What is the problem? Array store exception. I plus 1, j plus 1 to take. Oh, wait. We did some mistake. Okay, no, that's fine. 36 arrays dot fill. Oh, this was a mistake. Sorry, my bad. Row. Okay, it will come row. Let's compile and run. Yes, we've got. Now let's submit it. Yes, the solution is accepted. Let's quickly see the C++ code as well. It's almost the same. Okay, so here, if you see, right, so we are taking this two-dimensional DP array, right? Two-dimensional DP array, and we are initializing with -1. And yes, I and j initially we are passing 0, right? And everything is same over here. J equal to M, right? If T is exhausted, right? That means we have found a match. Else, if T is remaining and S is exhausted, we are returning 0. If we have found the repeated sub problem, if we have stored that, let's return it. And here, if the characters are matching, we have two choices, to take and to not take. And if the characters are not matching, we anyways have only one choice, right? And then we are taking take and not take. We are adding the number of occurrences and we are storing the DP, right? So yes, so this is a solution. I hope you've got the solution. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.